Hey, this is Math 6, Unit 8, Lesson 14, comparing the mean and the median. Okay, so the mean we talked about as being something that is our typical or our average, and our median we've talked about as that being the middle value. Both of these are ways of talking about what is kind of the center of the data that we're looking at. But sometimes it's better to use mean, and sometimes it's better to use median, depending upon the situation. So here are two dot plots. The first dot plot shows the heights of the first 22 US presidents. The second dot plot shows the heights of the next 22 presidents. So presidents 1 to 22 and then 23 to 44. So based on the two dot plots, decide if you agree or disagree with each of the following statements and then be prepared to explain your reasoning. So this is something you're going to be doing as a class today, right? So first off, it says the median height of the first 22 presidents is 178 centimeters. So let's see, is that something you agree with or disagree with? It is something you can definitely check though, right? If there's 22 presidents, then we want to put the median somewhere about, after number 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the median would be right here on that number, which happens to be 2 in one space, so we're splitting up number 178. So that's going to be something that we can agree on quite simply. Okay? Now it says the mean height of the first 22 presidents is about 183, talking about the mean height there. Now I could calculate that and find out for sure what that is, but if they're saying that the mean is going to be right here, that they want to say that's the mean height, is that something that makes sense based upon what we see? If the middle of the data is here, that means that half the numbers plus 2 more are on this side of the mean, and there are only this many on this side of the mean. Plus the space from here to here is 183 to 193. That's a space of 10 there, or 183 to 163 is a space of 20 there. There's just not a way that all these numbers are going to balance out with this few number of numbers. So I'm going to disagree with that one right there. A typical height for a president in the second group is 182 centimeters. So typical, again, kind of looking at what might be kind of the center here. Is that a typical height about 182? Well, for the most part, this is fairly symmetrical, right? And that seems to be somewhere in about the middle there. So we could probably go with that's probably a good guess of what is typical or what might be the center for all the presidents in that second group. Okay, again, we could find out for sure, but it seems like a pretty good guess. U.S. presidents over time have become taller. Well, overall, we have a group that's over here, right? And the shortest presidents, in general, the shortest president is taller than the shortest president last time, and we have a large group of them that are here compared to this group right there. Let's say we draw a line right there. Okay, what do we notice? We notice that there's 3 on this side for the last 22, but there's a whole lot more on this side. So overall, the values for the second group tend to be more than the values for the first group. So we would agree with that one based upon what we see. The heights of the first 22 presidents are more alike than the last 22. Well, alike is going to be shown by, do you see it being, do you see some symmetry there? And when we take a look here, we have a nice curve there. And this data goes and is up and up. We have a couple peaks, right? Not as symmetrical. So as the first one's more alike, I would disagree with that one there. The second one seems more alike. They're much more clustered together. And the mean absolute deviation in the second data set is greater than the first one. Again, that's going to talk about the variability. So is there more variability in the second data set? We would disagree with that. There's less variability because it's more closely connected. There's a greater variability here, so this is going to have a larger mean absolute deviation. This will have a smaller mean absolute deviation there. Okay. So here's the first activity, really, besides presidents we're doing some math with, okay? Besides some predicting. Your teacher's going to give you height data for your class, which we used back in Lesson 1. So if you want to go back to Lesson 1, you might have some data from when you did this. This is Unit 8, Lesson 1 we did as a class. So if you have that as a class, you probably want to use those numbers to match your class. I did it back on mine, and it looked something like this, where I had 30 heights listed right here. It's hard to get them all on one screen. Almost get it. I can get 30. There they are. Just barely. I have 30 heights listed right here. it wants you to, first of all, for me, it says to find the mean height of your class in centimeters. So to find the mean, I need to add all of those numbers up. That's a lot of numbers there. So when I add all those numbers up, first of all, I have my class had 30 students in it, so I need to make sure I remember how many we had. And those 30 students, the sum total of all their heights was 4,527 centimeters. So I'm going to take that value, 4,527 centimeters, and I'm going to divide it by 30 in order to get the mean from the data we found back in lesson 1. So 4,527 divided by 30 is actually 150.9. So that's the mean of the data that we had. The median in this case is going to be the one right between 15 and 16. What are those values? Because that's going to be the median there right at that point. For my data set, my data that came at place number 15 and 16, in my case, were actually the same number. 15 was 154 and 16 was 154. So my median ends up being 154. Mine happened to work out that way. You might have had two numbers and you need to find the middle point there. So for my numbers, 154 was the median. Now we're going to use these numbers here, including this one, for the next activities. Suppose that the world's tallest adult, who's 251 centimeters tall, joined the class. Have a discussion about how that would change the mean height of the class and how would the median change. Okay, so think about having all these values here and we add to it 251. Now, in terms of the mean, because we're adding a large value, okay, we would expect the mean to probably increase. Okay, now the median would definitely go to the right, probably one place to the right. Now in my case, my one place to the right just puts it on the same number. So my new median is actually going to be exactly the same with no change there. But the mean will definitely change. I'm going to take the sum of the 20 students that I had and add to it the new height, 251. And I'm going to divide that now by the number of students, which is now 31, not 30. And that becomes 154.1. So my new mean did in fact increase, that did go up, that's true, and my median just moves over one spot, which is still the same digit because of just the numbers that I had. So in this case, which measure of center, the mean or the median, changed more when the new person joined the class? And in our case, we would say the mean changed more. It went up from 150, it went from 150.9, and it moved up to 154.1. It increased, which makes sense because we added a larger value to the whole set of data. Okay? The median is not going to change much because you're just adding 1 point, so it just moves over one place in the list, right? Just moves over one place in the list. Again, if you look back at my giant list, it's like this. My middle is right here at number 15 and 16. And so what's going to happen is what? Instead of being in the middle, we just make this the middle when I add one more value. And so I have 15 on this side and then 15 on this side by adding one more person to become number 31. Okay, now what happens though if we, next page, the world's smallest adult is 63 centimeters tall. Suppose that the world's tallest and the smallest of adults both joined your class. What would happen then? Well, in this case, some conversations you want to have is what's going to happen to the mean height? Well, we're adding a really tall one and a short one at the same time. So I would expect it maybe to increase a little bit, but maybe stay about the same, okay? So I would probably say maybe little change with the mean. And the median, because I'm adding 1 to both sides, let's say I had the numbers 4, 5, and 6, okay? What's the median? The median is going to be 5. What if I add two numbers? I add 0 and I add 100. Does it change where the middle's at by adding 1 to both sides of the middle? No. So in this case here, because I'm adding a tall and a small, I'm going to say it will stay the same. Okay? So the new mean. We find the new mean by taking our original total, which was of 30 kids, and we're going to add the 63 inches for the shortest person, and we're going to add the 251 for the tallest person. So this becomes 11, carry the 1. We have 8, 9 plus 5 is 14, carry the 1, 8 and 4. And we're going to divide that now by 32 students. So when we take that sum and divide that by 32, we end up with 151.2. My median stays exactly the same. It just happened to be that way. So in this case, how did the measures of center, mean and median, change when 2 new people joined the class? Well, before we were at 150.9 and it increased to 151.2. That means it had an increase of 0.3. That is very, very, very small of an increase for the mean. It did change, but not a ton. Okay, not much. And the median had no change whatsoever. So there's definitely a change with the mean, but very little change with the median. Okay? All right. So our next activity, we're going to be looking at some 6 cards. And your teacher's going to give you 6 cards to look at with a dot plot or histogram. And we're going to talk about what these cards, what they show, and talking about the distributions there. So the first thing you want to do is take your cards and you're going to sort them into 2 groups. You decide how you want to put them into 2 different groups based upon whatever you want to see there. Okay, and that's up to you for what you see and what you want to take a look at. Okay, so what are you seeing? All right, I'm going to flip my paper real quick. All right. Okay, so the first card we want to talk about, hopefully you've had a chance to look at things. If not, here we go. Here's card A. Card A is here, and it's talking about the dogs. And the card A, we see that's pretty symmetrical. We see that the mean is 7.8 and the median is 8. So I would group A to get A with one group of things that are kind of in symmetry, and they have similar means and medians. That's group A. Group B, we can see, is also symmetrical, a little tighter there, but it has some symmetry. And we have a 5 for the mean and a 5 for the median. So we have the same mean and median. So we see a pattern here. When things that are symmetrical, they seem to have similar means and medians. For C, while it may not be super symmetrical, it's not asymmetrical, so it has a little bit of a pattern there. But again, we see the same median and same mean of 12.5 and 12.5. These values are quite different from what we see on cards D, E, and F. Look at card D. We have this little peak here, and then nothing, and then a little bit there. Definitely not symmetrical. And when it's not symmetrical, what happens to our mean? Our mean here was 15. Sorry, my printer's a little out of ink. And my median was 8. So there's a big difference there when the cards are not showing symmetrical data. For card F, we have this huge peak here, and then it drops off. And again, we have a mean of 21.3 and a median of 15. Those don't match one another, not close to each other, which makes sense because this is not symmetrical. And finally, card E, we have up here, and then it just drops off. And we have 24 as the mean and 15. So again, a mismatch there, especially when you compare it to the other values that were either exactly the same as in B and C, or very close as it was in A. So what is typical? What is a typical age of dogs being treated at the animal clinic in card A? The typical age would be probably right about there, and we would say about 8 years old. That makes sense for the dogs. What is a typical number of people in the Irish households? Well, the Irish households, the typical one is going to be this large one here. It's in about the middle of the data set. So we would say typical number of people is right there at 5, because between 4 and 6, we'd say 5. What is a typical travel time for a New Zealand student? Again, if this is going to be pretty symmetrical, we can look for where's about the middle of the data here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the middle is going to be somewhere in between 10 and 15. So we'd say that's going to be about 12.5 as well. So we'd say typical time for travel is about 12.5, which is both the mean and the median's value. Oh, sorry, I was writing off the page. So 8 for the dog, 5 for Irish households, and 12.5 for walking. D. Would 15 years old be a good description of a typical age of people who attended a birthday party? So 15 is here. Would this be a good description for the ages, meaning is the mean a good description of the age of people at the birthday party? No. There was nobody who was 15. In fact, most people at the party were about, looks like, 8 years old. The median would be a better choice. But, so we would say no to that one. No, it wouldn't be. And that's because 8-year-olds attended. So that's a little bit too high of a good description. In card E, it says, is 15 minutes or 24 minutes a better description of typical time it takes for students to get to school? 15 or 24, meaning looking at this data set, what's the better number to use? The 24, which is the mean, about here, or do we use the 15 as the middle number of the data set about there? Based on what we'd see there, probably 15 is a better choice there to use. It's more the middle of the data and probably just a better one to use to describe what's happening in this chart. 24 doesn't make a lot of sense, but we can say 15 is about right. That covers half the people there, and these people are a little bit extreme over there. And finally, would 21.3 years be a good description of typical age of the people who went on a field trip to Washington, D.C.? So 21.3 is going to be here. Well, first of all, there's nobody in that age group that went on this trip. Most people were between 15 and looks like, 15 to 18 years old or so. And that's the median age is 15. So I'm going to go with no, that would not be a good thing. We probably want to go with something smaller because most of the people were teenagers there. So we would say no to that one. So how did you decide which measure of center to use for the dot plots? Well, in A and C, for all those ones, the mean seemed to be a pretty good value. It seemed to work well. When the data is symmetrical, okay, and this mean usually works pretty well. For cards D and F, what worked better there was the median, right? And that happens when it's not symmetrical. When it's not symmetrical, that means that some pieces of data are going to pull the mean in one direction or the other. So it's better to use a median in cases like that where it's not symmetrical. All right? Okay, so in summary, we're going to look at the last paragraph of this whole summary page. You can read it all if you like, but the last paragraph is probably the key one takeaway here. In general, when a distribution is symmetrical or approximately symmetrical, the mean and median values are close. So when it's symmetrical, mean and median values are close together. But when a distribution is not symmetrical, the two values tend to be farther apart. And then you have to decide which one's better to use, and typically it's better to use the median when the values are further apart. All right, we're going to pause there, let you do your homework. We'll come back and check it together in just a few minutes. All right, welcome to your homework for lesson 14, comparing mean and median. So here's a dot plot that shows the ages of teachers at a school. Which of these statements is true of the data set shown in the dot plot? So this is the ages of teachers at the school. We have a cluster here between 30 and 40. And then we have some ones sprinkled up here and some up here. So, is the mean is less than the median? Well, when I look at this here, my median, there are 28 people in this plot. So I went ahead and figured out where's the median at. It's at 14, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is there. So that means that that's my median spot at 14, between 14 and 15. So my median is going to be right here between these values right there. That's my median value. Okay. Now my mean value could be similar to that as well. Hard to say. But probably because I have these large values here, my mean value is going to be on this side over here someplace, if I had to guess. It'd be nice if it was here in the middle, but these values are going to pull it that direction. So is the mean less than the median? No. Is the mean approximately equal to the median? Not because of these numbers, it's not going to be. Is the mean greater than the median? Yes, it is. Cannot be determined. It could be. We could figure it out. We're just not going to. Number 2. Priya asked each of 5 friends to attempt to throw a ball in a trash can until they succeeded. She recorded the number of unsuccessful attempts made by the friends. There's a 1, 8, 6, 2, and 4. Let's put them in order real quick. There's a 1, 2, 4, a 6, and an 8. but she made a mistake. The 8 should have been an 18. So it should have been 1, 2, 4, 6, and 18. How would changing the 8 to an 18 affect the mean and median? Well, median's the easiest one here. What happened to the median by changing the 8 to the 18? Nothing. It stayed the same. How about the mean? The mean, we added 10 more to what we were doing, so I would expect the mean to increase. So where does that take place at? Well, one of these choices says the mean increases and the median stays the same. I'll let you circle that one on your own. Number 3, in a history class, Han's homework scores are 100, 100, 100, 100, 95, 190, 100, and 0. The history teacher uses the mean to calculate the grade for the homework. Write an argument for Han to explain why the median would be a better measure to use for his homework grades. Okay, so the median is the middle. Think about this. If you put these in order, you have 0, 90, 95, followed by 100, 100, 100, 100, 100, and 100. So the median is going to be the middle number of these 9 things. We're going to go 1, 2, 3, 4, 5. So why would he like the median? The median is going to be 100. Why would he not like the mean? The mean includes that 0, so you're going to see a decrease in the overall average. It's going to pull his score down, where the median shows that he's been pretty good over time. He just had a terrible day. Maybe he was absent. I don't know. Right? So write a little argument for why the teacher should use the median to help Han out. Number 4. The dot plots show how much time in minutes students in this class took to complete each of 5 different tasks. Select all the dot plots for which the mean time is approximately equal to the median time. So we want the mean and median to be the same. For that to take place, we've said before, we should look for things that are symmetrical. Okay. If it's symmetrical, we're going to have that take place. Okay. So we want to look for something that shows good symmetry. That's going to usually mean those are going to be aligned. So let's take a look at what we have. Where do you see symmetry at? Well, this one, the first one, maybe, it's hard to say it's symmetrical. It just kind of goes up there, disappears, and comes back. So I don't think that's going to work. This one seems to be pretty tight. That looks okay. C seems to be fairly symmetrical. Looks okay. This one we go up and down, so no. This one we go up, and down, so no. I'd go B and C because they are symmetrical. 5. Zookeepers recorded ages, weights, genders, heights of 10 pandas at the zoo. Write 2 statistical questions that could be answered. Here's one. I'll give you one. So what is a typical weight of a panda at this zoo? And that's one. You can come up with another one there. Okay? And our last one, we're going to draw and label. We have Y, we have X, and we have some points here to plot. Okay, we can see we have 1, 0, 4, 1, so I'm going to go out to 4, 1, 2, 3, 4. And for our Y, we're 0, 0.5, 3.5, so I'm going to go up to 1, 2, 3, 4. So the first point is 1, 0, so that's here for A. B is at 0, 0.5, so that's B. C is at 4 and 3.5, so there's C. And D is at 1.5 and at 0.5, so there's D. This should look something like that. Alright, that's it for today. Have a great day, and we will see you next time.